In this video, we're going to shift gears a little bit and take a break from equations, and we're going to talk about something called inequalities. And these are things that are making comparisons between two quantities that aren't particularly equal to one another. So what I have on this screen are a bunch of statements, and they all mean almost the same thing, but they all have very subtle differences between each other. So I want to look at these 5 statements, and I want to translate them into a math sentence so we can see that what kind of comparison symbols we use to express these ideas mathematically. So the first one, I have $100. So if you think of that statement, I have $100, that means I have exactly $100, and I can't have $99 or I can't have $1,000 in my pocket. That means I have $100. That's exactly the amount I have. There's only one solution to this, and that is X equals 100. I have exactly $100. Now compare that to the next statement. I have less than $100. Well, how much money could I have if I have less than $100? Well, there's not just one answer to this. There's actually many, many answers to this question, or possible answers to this question. So I don't have $100. I have less than $100. So we're going to use something called an inequality to express that. We're going to use the less than symbol. You've probably seen that before. X is less than 100. That means it's anything less than 100, but it means that I cannot have exactly 100 because 100 is not less than 100. So I could have $99.99, but I could not have $100, or I could have anything less than $100. The next one, I have more than $100. Very similar, but it's kind of the opposite. Now I have everything that is greater than 100, so we use the greater than symbol. So I could have $100.01 and anything more than that. But again, I cannot have $100 exactly. I have to have more than 100. So we still use 100 as our comparison benchmark here, but X has to be greater than 100. Now compare that to the next 2 statements. I have at most $100. Well, that means I could have $100, or I could have less than $100. So now we need to have a symbol that communicates this idea. So X is going to be less than $100 or equal to $100. So I could have anything that's less than $100, or I could have $100 exactly. So we use what's called the less than or equal to symbol. That's the less than symbol with a little line under it, or half of an equal sign. And then the next one, I have at least $100. That means at the smallest amount, I have 100. So I have more than 100, or I have 100 exactly. So X is greater than or equal to 100. So all of the ways we can compare the amount of money I have to 100, we have math symbols for. So we have been using the equal sign. We've been talking about equations, but now we're going to focus a little bit on these bottom 4 symbols, the greater than, less than, greater than or equal to, or less than or equal to symbols. So here are the symbols and what they mean. So we often get these flipped around or confused. The less than symbol is pointing to the left. So less than is left, or it kind of looks like an L that's kind of crooked a little bit there. The greater than symbol is pointed to the right. Less than or equal to is the less than sign with the line under it, and the greater than or equal to sign is the greater than symbol with the line under it. So remember, inequalities compare quantities that are not exactly equal. They could be equal or they couldn't be equal, but they're not exactly equal like we use the equal sign for. And inequalities describe situations in which there are many solutions. That's something that's key as well. Equations give us one possible solution. Inequalities give us a lot of possible solutions, and we have to make that distinction. So let's practice writing an inequality to describe these situations. Amelia sold more than 40 magazines. So 40 was kind of the cutoff, but it doesn't mean she sold exactly 40 magazines. In fact, she sold more than that. So if we use M to represent the number of magazines she sold, she sold more than that. So the number of magazines she sold is greater than what? Greater than 40. It has to be more than 40. So she could have sold 41, 42, 100, 1,000, a million. Anything that's more than a 40 is a solution to this inequality. Next one, Gina sent less than 35 texts yesterday. So if T is the number of texts that Gino sent, they have to be less than 35. So Gino could not have sent 35 texts exactly in this case, had to send less than 35 texts. A student must have at least 10 hours of instructor-assisted driving time to pass the course. So at least 10. So at the minimum, this person could have 10. So if we let H be the number of hours that they need, they could be 10 or more. So if they had 10 and a half hours, 11 hours, 12 hours, so anything that's greater than 10 or equal to 10 is going to be enough to pass the course. So the number of hours required to pass the course is greater than or equal to 10. So now let's take a look at some actual algebraic expressions here that contain inequalities. And remember, inequalities can have many solutions. And all we're going to do to check all we're going to do is check to see if the given value is a solution to the inequality. So here is our inequality statement. 3.9 plus x has to be less than or equal to 12. And we're checking to see if this is a possible solution. Can x equal 6 and still be a solution? So what we're going to do is just plug that into our inequality. 3.9 plus 6, is that less than or equal to 12? 3.9 plus 6 is 9.9. Is 9.9 less than or equal to 12? Yes. So this is a solution. What about the next one? Y minus 1/3 has to be less than 1. Here is our inequality. And we are testing to see if this value of y will make that inequality true. So we're going to plug that in. 4/3 minus 1/3 is less than 1. 4/3 minus 1/3 is 3/3, which is 1. So is 1 less than 1? No! That is not a solution. So 4/3 is not a solution to this inequality. Anything that is less than 4/3 actually is going to be 1, but we'll get into that another time. Sometimes it's helpful to show all the possible solutions to an inequality on a number line. So we're going to show all the possible solutions by plotting them on a number line. So if we look at this example, A is greater than 6. That means A is everything greater than 6, but not 6. Okay, it could be 6.00001 and may still be true, but it cannot be 6 exactly. So since A cannot be 6, we use an open circle right here that I have an arrow, 2 arrows to, and draw an arrow to the right to show all the values greater than 6. So we use an open circle on 6 because that's kind of the cutoff point. That's the border between true and false values. Anything greater than 6 will make this true. So we're going to fill in our number line to the right to show that anything that is bigger than 6 is a solution. So anything in the red is going to be a solution to this inequality. Anything to the left of that is not. So 6 is not a solution. 5 is not a solution. 4, 3, 2, 1. All of those values are less than 6, not greater than 6. So all the things to the right of 6 are greater. Likewise, if we look at this one, x is less than or equal to -1. That means x is everything less than -1 or equal to -1. So since x can be -1, it can be equal to -1, we use a closed circle. And we're going to show an arrow to the left to show all the values less than -1. So a closed circle means that that value or that point on the number line is included as a solution. And then the open circle shows us that it is not included as a possible solution. So here is a nice thing to put in your notes. Graphing inequalities, whenever we have the less than or equal to or the greater than or equal to symbol, we're going to be using the filled circle on our number lines, and the less than or the greater than symbol is going to be using the open circle because that value is not included as a solution. So let's practice that. Here are a few inequality statements, and we want to show the solutions to these inequalities on the number line. So x is less than 5. So x cannot be 5. So I'm going to put an open circle on 5, and then everything less than 5 is going to be where I'm drawing my arrow. So that would be to the left of 5 on the number line. So I go ahead and draw a nice arrow to indicate that everything to the left of 5 is a solution. Now, a lot of people like to put the circle on 4 because that's the first number that's less than 5. And that's not actually true. Remember, 4.99999 repeating could be a solution to this, so we can't just put our dot as close to 5 as possible. That's why we use the open circle instead. Next one, x is greater than or equal to -2. So -2 is a possible solution because of the or equal to part of that inequality. So I'm going to put a closed circle on -2, and then everything greater than -2 is going to be to the right of -2 on the number line. So I draw my arrow to the right and fill that in to show that everything is greater than -2. And then the last one, x is greater than 0. 0 is not a possible solution, so I'm going to put an open circle on 0, and then everything to the right of 0 is going to be greater than 0, so I draw my arrow to the right to show those are the solutions. So that's graphing inequalities on a number line. Pretty straightforward to do that. Now we're going to do the opposite. Here I'm going to give you the graph, and we have to come up with an inequality to match. So we can see that we have a filled in circle on -3. So -3 is included. So this is going to be or equal to, and it's everything to the right, so it's everything that is greater than or equal to -3. So x is greater than or equal to -3. And then the next one, -2 is a kind of our cutoff point. It is not included as a solution, and it's everything to the left, so that's everything that is less than -2, but not including -2 as a solution. So that's inequalities, our 4 inequality symbols, greater than, less than, greater than or equal to, or less than or equal to, and then showing solutions to those inequalities on a number line.